Hi guys, welcome back. And this one will be taking a look at exception handling and how that actually works within the context of our process of actually building up distributed applications within Python and Celery. So this is a very key important lesson that everybody should have a good fundamental understanding in terms of how exception handling actually occurs and how you actually gracefully ensure that your applications don't terminate. So whenever we're building distributed applications, it's very important to always take exception handling very seriously, because what you're doing is you're actually building distributed applications or distributed processes that are running in the background, and you want to ensure that those processes will be able to gracefully exit or gracefully terminate or even gracefully retry in the event of any kind of erroneous error that actually occurs within your program. So in this lesson, we'll be covering more about the basic fundamentals of exception handling and how that actually fits in to the context of building our distributed applications within this particular course. So in order for us to have a better understanding, we need to take a look at the definition of what an exception is. So an exception is an event that occurs during the execution of a program that disrupts the normal flow of the program's instructions. So this is a typical Wikipedia definition that if you Google up what is an exception, this is kind of like the definition you get of what an exception is all about. So we're going to dive a little bit deeper in terms of code so you can actually see how exception handling actually works and what are those errors that can potentially occur within your application. So within the context of Python, we have this kind of like hierarchical structure in terms of how exceptions are basically built into Python. So we have a base exception, then we have an exception which inherits from your exception, then we have an arithmetic error exception, lookup error. So basically all these kinds of exceptions form like a kind of like a Christmas tree where everything is all inheriting from the base exception class. So you as a user will be able to actually create your own exception. So we're going to dive a little bit deeper so you guys kind of get an understanding of how this actually looks like in terms of inheritance when you're building your own exception classes, so you can kind of get a picture of this hierarchy that actually forms within Python based on inbuilt exceptions and other exception classes that Python uses, and how to actually create your own custom exception class so that you can throw that exception around and you can catch that exception around. So this will all make sense once we actually dive deep into the code. So in the next part of the lesson, we're going to jump in and take a look at some code examples so you guys kind of have an idea of how all this kind of fits together. Let's jump in and take a look at how exception handling works. So we'll start off with a program that does not have exception handling, then we'll move on to a program that has exception handling. So we'll write a simple basic program that accepts user input on the command prompt, and then we'll print out the actual result. So we'll type in salary here as a value, and what we're going to do is we're going to cast the salary value that we're going to input on the keyboard, and we're just going to go ahead and actually print salary out. So let's go ahead and actually fire this program, see what actually happens. So if I try to fire the program, it will ask me, please enter your salary. So we'll go ahead and actually type in a positive integer value, and you notice that the integer value is actually printed. But if I rerun the same program again and this time enter a string, what will actually happen? We will get an exception. So the exception that we get is actually value error. So this value error, if we head on over back to our Python hierarchical diagram, you actually notice that the value error will be a built-in type called value error that is actually inherited from our base exception class. So what we're actually doing here is we are illustrating a simple example that illustrates an exception that gets thrown if we enter the wrong input. So let's take a look at an example of how do we actually convert this little piece of code so that we can actually catch exceptions and handle them gracefully so that our program just doesn't terminate and exit as illustrated. So let's go ahead and actually tweak our code so that we can actually gracefully handle exceptions which occur whenever a user enters the wrong input. So what I'm going to do here is just put a try, and I'm going to wrap all this code into an except value error. And then what I'm going to do here is just put a print statement that says print invalid salary amount. Please try again. So what we're going to do here is we just want to ensure that we format our code. So within Python, ensure that you put the appropriate full spaces or a tab. So while true, just do this particular statement here. So this is an iteration that keeps looping until we actually enter the correct input. So here's the thing now, this particular loop will actually continue to loop without actually exiting. So for us to be able to actually break the cycle of the iteration, what we want to do here is just put a break statement right at the bottom here. So what we're saying is, in the event our input is correct, print the statement, then break. So take note, the try except exception handling works in the event that if our integer casting here actually fails, what will actually happen is the except command here will be executed and it'll print invalid salary amount. So this cycle will continue to repeat and the break statement actually never gets called unless our casting of string to integer actually is successful. So once we fire up our code, if we try to enter any invalid data, which is a string, it'll say invalid salary amount, please try again. So this process will actually continue to happen and we can see that our try catch mechanism is actually working. So what happens if we actually try to enter the correct result? So I'm going to try and enter a correct integer value. When I type that in, our program gracefully exits. So this little concept here actually illustrates a basic example of how exception handling actually works. We want to take a look at creating your own custom exception class, something like what we have here, which is value error. So you guys can understand how the Python exception handling hierarchy actually works, so you can get that into a more clearer picture in terms of how do you actually define your own custom exception class and how do you catch that exception class and how do you actually gracefully handle your own custom exception classes. So we'll take a look at that in the next section of this lesson. So let's move on and create our own custom exception class. So if you want to create your own custom exception class just like this value error here, all you have to do is just create a class and call it, for example, salary error. And what we want to do is we want to inherit from the exception class itself. So once we do that, all we can do is just place pass. If you want, you can actually define your own constructor here that inherits from the base exception class, and you can pass additional arguments. But we're going to keep it simple, and we'll just put a pass here so that this particular salary error will just inherit everything from the base exception class itself. So once we do that, all we need to do if we want to use this particular exception class is actually define it within our code here. So what I'm going to do here is, instead of catching value error, what I'm going to do, I'm going to replace this with our salary error class right here. So once we do that, we need to raise a salary error, because what we're doing here is we're actually getting a value error whenever we cast this string here into an integer. So what I'm going to do here is I'm just going to convert this code so that I'm going to detect whether the input is actually a string or not by performing validation, and if the validation fails, then I'm going to raise, basically I'm going to introduce a new keyword here which is called raise. I'm going to raise a salary error and this except will catch the salary error. So let's go ahead and actually tweak our code in order to perform a little bit of validation so that we can actually use our custom salary error exception class. So in order to do that, what I'll do here is just remove this integer here, and what we're going to do is just to check whether the salary is actually an integer. So what we're going to do is just put an if condition. If not salary is digit, then what we want to do is we just want to raise. So raise is the new keyword that we're using here, and what we're going to do is just raise salary error, and we're going to add our colon at the end of our if statement here. So the only difference within our code now is we're actually accepting a string input, and we assign this a variable called salary. Then within salary, since it's a string input, then we're checking whether it is a digit. So if it is not a digit, what it'll do is it'll raise a salary error, and if it is a digit, it will just continue and print out the salary, and the program gracefully exits. So this is a typical example of how you can actually create your own custom exception class that you can leverage on within your source code. So this basic example that we've seen so far is basically all you kind of need to understand in terms of exception handling and how you can actually do that within your salary based workers. So it's very important, because whenever your workers are distributed, you don't have a lot of visibility, especially if you don't have a UI to be able to track your workers, whether they're in a healthy state, whether they've actually errored out or not. But later on, as we go deeper into salary, we're going to take a closer look at how we can actually build our own exception handling mechanisms within our distributed workers so that we can get more visibility in terms of whether the worker is in a healthy state, whether it's actually errored out, whether we have properly placed exception handling so that we can actually put in retry mechanisms. So the whole idea is you just need to ensure that you understand that whenever we have a possible exception that's going to happen within our source code, we ensure that we wrap it between a try and except. So try says try this piece of code here, and if there's an error, run the except portion of the code and gracefully either handle the error or close the resources that are being utilized or perform any kind of cleanup. And you also have something else that you guys can leverage on, which is the finally block, because so far we've actually talked about try and except. So let's dive in a little bit more and discuss about finally. So the finally block actually precedes the except function here. So what you can do is you can just go ahead and put finally, and what you can do within the finally block, you can actually put another print statement and says this will get executed no matter what. So what the finally block actually does is, in the event that we have an exception, it will always run the finally block. So finally actually gets used in cases where we have certain resources that are being consumed, and we want to ensure that these resources are released in a graceful manner regardless whether there's an exception or not. And we actually forcefully ensure that whenever we execute this little try catch exception, this finally block will always execute. So this is one of the key things you also need to remember whenever you're doing exception handling within your workers or distributed tasks, is ensure that you always have a finally block if it's applicable, and you really need to ensure that something gets executed regardless of the event that occurs. So with the finally block in place, let's go ahead and actually fire our program again so that we can basically have a closer look at what's actually going on. So if I actually execute my code here and I type in the wrong integer, you'll notice that this will get executed no matter what. So this is always there. So this illustrates how the finally block actually works. If I go ahead and enter a real number, it'll gracefully exit and the finally block still gets called again. This pretty much encompasses how exception handling works. You can either use built-in classes that Python already provides, or you can put your own classes and define them and ensure that you raise them within your code. So most Python code that you might read through, you will notice that the same concepts are applied virtually everywhere. If you need further resources and information, you guys can always leverage on Python documentation. They have quite a lot of extensive API libraries documenting what are the inbuilt exception handling classes available. So you guys can check out this particular website here on Python main website. So do ensure that you're looking at the appropriate version if you're using Python 3. Virtually the same in terms of some of the inbuilt classes that they provide. So make sure that you use the correct classes whenever you want to raise an exceptions that illustrate the type of exception that's actually being raised. So for example, we have always error here, then we have a description. This exception is derived from environmental error and is raised whenever the function returns a system related error. So each particular inbuilt exception class has use case in terms of when it will be actually be raised and when you can actually raise it. So you can actually read through the documentation and see, do I actually need to raise this kind of error? So if I have a validation error, for example, I enter the wrong input, or I have a floating point error, then I will raise this particular exception so that other developers as well will have a better understanding, because they know, okay, if there's an attribute error, it means what? If there's an assertion error, what does that actually mean? So it's very important that you also understand the inbuilt types of exception classes that Python actually provides. And if Python doesn't have something applicable for your use case in terms of an exception that you want to raise, you can just go ahead and actually create your own custom error class that you can leverage from. So I hope you guys enjoyed this lesson. I will see you in the next one.